Hi class, how you doing? Praise God, glad to be able to come back for you with another week of lectures. Yes. This week, database systems. I know this week it says we're doing, if you look at the syllabus, database systems and big data. But I will tell you, the big data section in the PowerPoints that are already there are really good. So I'm just going to kind of do a little deeper dive into database systems. Now, I have to do a disclaimer right up front. I am not a database guy. And I'm sure there's some of you guys who have a lot more experience in databases that probably should be standing here teaching this. So, but I do have some knowledge, experience in databases. So we're going to dig a little deeper together here. So there may be some areas, if you want to drill down farther, by all means do. But I just want to kind of go a layer deeper than what the PowerPoint was originally presented with the syllabus. So now, picking up from last week, if you remember last week, I had talked about this model, right? The DIKW maturity model, and data, information, knowledge, wisdom, and understanding. Well, we're just going to pick it up from there as well. But really now we're going to get more into data. And we also talked about types of data. Structured, unstructured data. If you remember the differences between the two, gave you the example of YouTube. If you think of all those videos that are out there on YouTube, most of that is what we call unstructured. It's just, bits, ones and zeros. And about 85-90% of the data that's out there in the ethosphere is unstructured. But how are we able to catalog and categorize and actually make some type of sense and some type of decisions out of that data? We have to have a structure behind that. And really that is where our databases come in. So what is a database? Well, we talked about data. Data, that's really the building blocks of your information. And everybody wants good decision quality data. So a database is what we use to share and integrate some type of structure that allows us to store and collect raw data and be able to manipulate it and do things like queries and now be able to pull information out of just data. Now, within that, we have what we call a database management system, DBMS. Now, what is that? That's a collection of programs, and that's really there to manage how we extract data from a database. And some of these programs are things such as, MySQL or Access. If you're a Microsoft person, you may have worked around with Access. So that is a database management system that's very popular. But there's many, many, many other databases out there. Oracle, and the list kind of goes on and on, just depending on what your applications are and what you need to do. Now, another thing to understand about data is what we call metadata. Metadata is data about data. And what do I mean by that? So let's say if you have a piece of information, a piece of data that's collected. Well, there are certain things you want to know about that data. It's kind of like your picture. Have you ever taken a picture with your digital camera, right? And that picture itself could be considered data, right? That's a collection of digital information that is a picture. But if you looked at your camera, you can open up a window on your phone or your camera, and it will tell you what the aperture setting of your camera was, what the time of day, with the ISO, all of those things, all those settings in your camera, it's going to give you that information. And that's what we call metadata. That is data about data, or data that represents and complements or expand the value of your data. So what is a database management system, like an Access? What do these things do? And really what it is, it provides or it manages the interaction between, like we say, end users and the database itself. And we talk about the database, that's really the storage and collection of metadata. It's all the attributes, it's the products, all those things that's being stored. What the database management system like Access or any of those do, it is what's able to do queries and go and reach into the database and extract what we need out of it. So that way, different end users, and those end users could be people, or it could be other systems, other information systems, or other applications that request data from another database. And so that happens all the time. So when we think about an entity, you hear the word entity, that's what we're talking about, is a person or another machine that has a requirement or a request for information. Now, what does the DBMS do? They really do. They really improve data sharing, and also helps us to, if done properly, it helps us to improve security. Now, I will tell you that is a foot stomper, because anyone if you've built databases, you will know you want to be sure that you're doing things that we call like input validation on your fields. So even if you're doing spreadsheets with Excel or database with Access, you always want to be aware of input validation. This is especially true with web-based databases. These are the databases that run in the back end of our website. So let's say you go to Amazon, you want to order something from Amazon. Even though on the screen, what we see all these beautiful pictures, and we can scroll through those pictures and read information about that. But on the back end of that, there is a database that's managing what we order, how we order it. And so when they're building those databases, they want to be sure that the only thing that can go in a field is what's supposed to go in a field. For instance, if it is a field that says social security number, I do not want to be able to type text into that field. So I should validate the data, meaning when I create the database, so that the only thing that a user can put into that field is 7, 8, 9, 10, 11, 12 numbers and maybe spaces. But normally I want to put a template in there so that those little dashes will come up automatically, so that all they can type in is numbers. 111, 22, 33, 33. Their social. So that means that now that field is validated. And why is that important? Because from a cybersecurity perspective, without valid field validation, if I can go in and type text into a field like that, I may be able to do a SQL, an injection into that actual database and corrupt it, or have it to have some other types of nefarious activity go on. So that's why you always want to be able to do that. I know I kind of went off on a tangent, but I always have to throw a cyber nugget out there as we talk about databases, because it is so critical, especially with databases. Another great thing about database management systems is that it helps to minimize data inconsistencies. The human error, is quite prevalent. That if I have to sit and type a lot of data in myself, I'm prone to mistakes. But if I'm using a database, it helps to reduce the amount of human errors and maintain consistency, because now I can do data scrubbing, I can do deduplication, deduplicate records, I can find multiples, and many ways of making my data more pure, more relevant, and more attractive. So when we think about databases, years ago we always just had a lot of file systems, which is okay, that's great. But some of the things that just a regular file system, and when we talk about a file system, this picture here at the bottom kind of gives you a layout of what a file system is. Let's say in an organization you may have a personnel department. They've got their files. You've got sales department, and they've got their files stored on a server somewhere. And you've got accounting department. So all these departments got their individual files, and it makes it very difficult to do file sharing. Now, what a database system does is kind of the diagram at the top. Now I can still have these departments, these organizations, but now my database, and I have a central repository with these files as opposed to individuals. So now I can share files, and if I need to, I can do types of data blocking, so I can block files so that, for instance, if I have an auditing team, I may not want the auditing team to have direct access to my accounting files or my sales files, just so I can set up ways to delimit that. So, but as you see, a regular file system doesn't give you the flexibility, doesn't give you the ability to do many things that a database can actually do for you. And so as we compare just a file system to a database, I think it kind of shows you how it's a little more relevant as we use databases. Now, let's talk about data models. Data models. What is data models? Actually, it's pretty simple. It's a simple representation of a complex real-world data structure. And why is that important? I'm sure we've all seen, this diagram, right? Or a variant of it. Starts over this is what the customer asked for. This is how, department developed it, and it just goes through the whole thing. I'm not going to read all those. But without a data model, data and information can be misrepresented. So from what the customer said to what the customer actually wanted can be completely different. And how everybody interprets that in the middle can all be very different unless we're all speaking the same language, unless we're all in the same syntax, we're using the same semantics. And that is the purpose of a data model. It is really just to bring understanding to our data, especially with complex data. And here's why. Because we all hear and see things differently. If I have a database and I say, well, about clothes, and one of my fields is color, and I say I want it red. How many different variants of red do you think there are? And even of the same variant, how I may describe red will be completely different than how you would describe red. So without a succinct data model so that we're all speaking the same thing, so that when we say, instead of saying maybe red, we're talking about a specific number that everybody knows is associated with this color. So now I call it that number, that we know that it tracks back to this. So that way my data is programmed, is cataloged, and is properly. So when I build my database, there will be less confusion on what I'm talking about within that arena. So for me, especially with what data models help us do, is help us build things. And this is something I always tell my wife whenever we're out doing our little construction projects and things in the house or whatever we're building. I tell her I build it 3 times. I build it in my head first, I build it on paper, and then we go out to the shop and I build it for real. And and data models are very similar because you can have a conceptual model, you can have a logical model, and you have a physical model. Now, I always have to find opportunities to put a scripture in there. You know this, guys. You know this. So when I think about a conceptual model, it's a vision. And I love Psalms 29:19, which says, where there is no vision, the people perish. So we got to start with the concept, meaning the vision, the large vision. Now we bring that down to a logical model. And that is my write it down. That is where, if we're building a deck or whatever, okay, I got the plan in my head, but I got to get that thing on paper. And that's long before I start cutting wood and measuring. So I'm drawing, I'm making things like that. Logical model. And if you think about Habakkuk, chapter 2, verse 2, says something very similar. And the Lord answered me and said, write the vision and make it plain upon tablets, that he may run that read it. So even the Holy Scriptures are telling us the same thing. Write it down. Make the vision clear. Make the vision plain. You think maybe God knows something about data models? Nothing new under the sun, is it? And then we got a physical model. So after I've thought about it, I got a vision, I've drawn it out. Now, hey, all right, baby, let's go. We're going to go out to the shop. We get the ruler. We got the saws. We're getting ready for the sawdust to start flying. But still, even there, what is the carpenter's motto? Measure twice, cut once. So we still want to do that. Now we're ready to start with the works of my hand. And really, Psalms 90:17. I love this. And let the beauty of the Lord, our God, be upon us, and establish thou the work of our hands upon us. Yea, the work of our hand establish thou. So now we can, after we got the vision, we've made it clear, we've written it down, now the Lord will bless the works of our hands. It works in a spiritual concept as well as a natural concept. So now parts of it, what are some of the components of this data model? Well, I think we talked about entity, right? A little bit already. Anything about which data is to be collected and stored. That's an entity. Okay, what is an attribute? That's a characteristic of an entity. Okay, for instance, let's say an entity in a school, a high school, roster spreadsheet would be an entity, maybe student. That's an entity in that database. Now, an attribute would be student name. Grade that the student is in, what year. Those are attributes that describe that student. address, next of kin. Those are all attributes. And from there we have relationships, and that describes associations among entities. Now, different types of relationships that we talk about, really three basic relationships, are one-to-one, one-to-many, and many-to-many. Let me use an analogy to explain this, if I can. I love analogies, and I usually make them up on the spot, right in front of the camera, which is never a good thing. But here's an analogy. In your local church, your pastor, you and your pastor, you have a one-to-one relationship. You know your pastor knows you. One-to-one. Now, the pastor with the rest of the congregation is a one-to-many. One pastor who knows many people. So there's a one-to-many relationship. Many-to-many would be the congregation altogether. It means there are many people in the congregation who also know many other people in the congregation. So that is a many-to-many relationship. One-to-one, one-to-many, or many-to-many. So when we talk about relationships, those same things are very critical that we grasp when we're thinking about database and database management systems and how our data model and how we're going to set up our database. Because within our data tables, we need to know going in, is this a one-to-one, one-to-many? And most of the time, many times, especially as we talk about relational databases, it is a one-to-many relationship. Okay, so, and constraint, actually that's a restriction that's placed on data, meaning that now I can use my database to set parameters that my data have to conform to within a given arena. So when we think about a relational database model, like I said, so this is just an example of a relational database model, and it allows you to do what? View data logically. That's a logical view of data based on what we call a table. What is a table? A table is a two-dimensional structure composed of rows and columns. Think about Excel, a worksheet in Excel. You've got columns, right? And you've got rows. The rows are numbered, columns are lettered. A through, I don't know, ZZ or ever how far it goes, and 1 to ever how far down it goes, okay? Now, where these rows and columns intersect, that's what we call a tuple. That's a tuple. In Excel, we call it a cell, but in databases, that's a tuple where they intersect. Now, so the example that we're looking at here is, what is this? Like a student database. And this is just one, what we call a flat table that has fields and rows and columns of information about particular students. And you see each across the top, they're labeled, that tells you what each of these rows, each of these entities, and what the information or what the attributes are of each of these students. So that's a relational model. Now what I can do within a relational model is I can have multiple worksheets, multiple, and now I can relate them together in a relational effect using what we call a key field. So if we look at this example, right? If we look at the account code, so I have a table. This table's name is agent, right? And it's just a database, a spreadsheet. I have another table that's named customer. Now, these two have different information in it, right? If you look, there's different data in each of these. But what brings them together is a key field, account code. So account code from the agent sheet marries up with the account code in the customer. So now, since now these two align, I'm able to extract data from this table. I'm able to extract data from this table, and by doing a query, and they're linked together, so I can pull, but they're always going to be linked. So now I'm able to extract different information. And this relational diagram is what we use to set up that relationship. And you see, I don't know if you can see it here on the screen or not, but this is showing you that this is a to many relationships, meaning that one field here may actually pull from several fields here. One to many. Hope I didn't lose you. Hope I didn't confuse you. If I did, I'm so sorry. And so we talked about keys because the keys are so important. Now, the list here gives you some of the major keys that we talked about, like a super key. A super key, that's an attribute or a combination of attributes that uniquely identify each row in a table. Each row. That's going to be your super key. You have a candidate key, as well as a primary, secondary, and a foreign key. Now, the ones I was going to focus on today, right here on this slide, is the primary key and the foreign key. Okay, let's take a look at our table that we've got here on this side. Let's get to the right side here. So at the top, this is a one-to-many relationship between painters and paintings. All right, so if you see the painter number, this table, the top one, right here, it contains the table name, which is painter, the primary key, which is painter number, or the painter number, and it does not have a foreign key. If you look at the table at the bottom, its name is painting. It's a different table. The primary key is painting number, and the foreign key is painter underscore number. Now, if you notice something there, you notice that the foreign key of the table painting is the primary key of the table painter. So what this is kind of based on, this was a spreadsheet that was, a database that's made to pull information about which painter painted which paintings. So now you see why it could be a one to many. And I think it was based on a museum, art display. So now you could have one painter that painted 10 paintings. And now, once I know that, now I'm able to pull other attributes out of the spreadsheet or the database based on the painter and who painted it. So the key thing here is understanding the keys. The key thing is understanding keys. Okay, I probably should have had a better word than key thing. The most important thing is understanding the keys, the key fields. So the primary key that now is associated with the foreign key of the other table. So that is how those keys, and you could have countless amounts of separate tables that are all linked together by fields, by a key field. And so now when I do a query, I'm able to pull data from lots of different tables and then put that together and present it to you, the user, as a from a database perspective, as data or as information. Because all of these right here, they have data in them. But when I extract this data out and I present it to you in a format that's usable, I've presented to you information. So that now you can gain knowledge and grow in wisdom and make good decisions. Another model that we use is called the entity relationship, ER, the entity relationship model. So the ER model, and this is a graphical representation of entities and their relationships in a database structure. Very similar, using that same analogy. Excuse me. If we look at we'll call it, there's two notations. One is called the chin notation, and these are two people, a person who came up with that. And then it's this crowfoot's model. They call it crow feet. If you look at a crow's foot, it's kind of the toes spread out like some of these annotations here. So what is it showing you? Very similar to the same thing that we just talked about. So the painter, a one to many, one painter can paint many paintings. A many to many, an employee, you could have several employees who have several skills. So that's a many to many relationship, and a one to one relationship, meaning that one employee could work at one store. And the crowfoot design just kind of shows you how to lay this out in a graphical representation. How we map entities together using the entity relationship model. One that's gotten very popular in the last few years is object-oriented model. Now, what an object-oriented model is, like I say, that's where data and the relationships, they're all contained in a single structure that's known as an object. So everything is contained together in that one object. And so objects, and they all that share similar characteristics, are grouped into classes. So you got objects that has all the data and relationships in it, and then these, if they're similar, they're grouped into a class. And then these classes are organized in a class hierarchy. And also you still have attributes within this that describe the properties of the objects. Now, one of the languages that we use to demonstrate or to describe the object-oriented data models is UML, which is a unified modeling language. And like I said, that's kind of here in the middle. That's showing you how we took this object-oriented representation and we represent it in a UML class diagram. So when we look at this object-oriented, so we excuse me. So we have a piece of data called invoice. Now here are the attributes of that invoice. Is the invoice date, the invoice number, where the shipping date, and the total. And here are the relationships. So you got a customer, and you have the production line. That's a one-to-many relationship. But that's all contained in one object. And what this makes it very easy to do now, using different languages like XML, extensible markup language, you're able to now export this object out to somewhere else, and makes it easy to move objects around. If you think about an object as a ball, and everything is there together. So now I can make it extensible, where I can actually move this out. But now I can use other languages, like say UML, to break it out and make it more graphical and more expressive. Or I can still use the ER model with the crow's feet to describe the relationships. But it's all contained in this object. Makes it great for internet and web presentation and web activities, where now we're moving data back and forth across the internet and places like that. So let's take just a quick summary of our data models. And really, there's two I didn't cover because they are still used, but not quite as much. Is the hierarchical, actually. And at the hierarchical model, it was a little more difficult to represent many-to-many relationships. The same with the network model. We still use it, but really we've moved more so to relational databases like SQL or Access, those types of databases. And then we still have the entity relationship. We talked about the ER databases. And from there we have more what we call semantic driven. And that would be our object-oriented and even our extended relational object-oriented databases. Now, when we say semantic-driven, what that means is that it's based more on how we speak, how you're able to communicate. Early databases, it was much less semantically driven data. And so, but as we look at, especially now, with Google and all these other technologies, where we're able to sit and type in pretty much anything and it finds it, that's based on the semantics. So that now that our back-end systems, our search engines, all of these things are getting smarter and smarter and smarter to where they're able to understand more from how humans interact. And artificial intelligence will probably take that over even farther, so where our data systems now can relate to more from a human semantic expressions as opposed to just data. So we talked about the hierarchical model. Like I said, we talked about the network model, relational model, the object-oriented model, and the extended. So in summary, let's wrap this up. What did we talk about today? Some data fundamentals. We really got kind of deep in the next layer down into database management systems and really data designs or data models, because at the end of the day, that's what really drives how you're going to design, how you're going to build, how you're going to do all these things with your database. Some other things that we didn't really touch on, but it's really talked about more in the PowerPoint presentation that's in the syllabus is data dictionaries and describing how do you describe your data and how do you catalog data and data sets. So don't forget to go over those things as well. Hey, listen, I hope this helped you out a little bit. We're going to pick you up next, probably in the next area with networking. All right, God bless. Take care.